Hello, Tensor friends. I got an interesting question here, and I'm paraphrasing it to make it a simple the question. I don't understand basis vectors as derivatives. So the ith basis vector is equal to the partial derivative of a position vector with respect to that ith coordinate. So in other words, this could be ex, and that would be x. This could be er, this would be r, etc. Okay, when I first started with this, I didn't understand this either until I went back to the basics. So you do understand this, you just don't know you do. Okay? So let's jump into it. Remember back, you had a function. We chose x squared. And the definition of the first derivative of that function was the limit as a small change. Think of it as a delta x. They always use a h. So that's what we'll do. Goes to 0 of that function plus that little change, the delta x, minus the function divided by h. Remember this? So let's actually put this function into this definition, right? So we get x plus h squared minus the function x squared divided by h. So let's expand that. And we get x squared plus 2xh plus h squared minus x squared. This cancels that, right? And we get this is left. So this h takes out that h. This takes out one of these h's. We're left with 2x plus h. So when h goes to 0, the answer is 2x. And that is, as you know, the first derivative of x squared is 2x. Right? So that was the definition of the derivative that we all learned. Now, let's expand that to a multivariable function, x and y. So let's say we got x squared plus 2y. Well, what's the derivative of that with respect to x, let's say? All right? So we just write it the exact same way. Here's the delta x added to x minus the function divided by h. We plug in everything that we had, but now we've got all these extra terms in here. But look at this. This guy here, there's a negative sign, so that x squared takes out that. This negative 2y takes out that. We're left with the same thing we had, is 2x. So this doesn't get involved in the derivative because you're taking it with respect to x, right? So you can think of vectors exactly the same way. All right, so you've got some vector which has an x and a y position. So let's say everything starts at the origin. That makes it easy, right? Now let's just add a small change in x to that, right? So now we have a new vector, which has a small change to the x coordinate, okay? And now let's write our definition just like we did above, right? So we've got this small change in x to x minus the original, the vector, divided by h. Now, you know the derivative of a vector is a vector also, right? So we're actually making a new vector. So let's do a specific example. Let's let the position vector be 2, 2, okay? And let's let h equal 1 to start, all right? So we got x plus h, so that'd be 3. Y doesn't change. This is the original, the vector. So what is the vector 3, 2 minus 2, 2? It's 1, 0, right? Because that's just a 1 in the denominator. All right, now let's make it smaller. So let's let h equal 1/2. Now what do? The exact same thing, but look at this. This 1/2 is also in the denominator. So that's like multiplying these two vectors by the scalar 2, right? So when it's in the denominator, the 2 is going to go up to here, and we're going to multiply those by 2, so we get 5, 4 minus 4, 4. What's that? 1, 0. Well, that's the same thing we got up here, 1, 0. Let's do it one more time. Let's do it by 1/4. All right? So we're dividing by 1/4. That's like taking the scalar 4 up here and multiplying these two vectors. And we get 9, 8 minus 8, 8, 1, 0. So we keep getting 1, 0. That's because it's a basis of vector. So let's go look at it graphically. Okay, so here's our position vector, 2, 2, right? Now, we're going to add to that and make a new vector with just some change in the x coordinate, okay? So there's our new vector with a change in the x, the coordinate, by adding this h in here. Now, you notice this h I added as a variable so I can change it, right? So I can move it back all the way back till it's right on top of it. Then it's the same vector, all right? Now, what we want to do is plot a new vector. This one, we'll call it ex, is going to be this vector minus this vector divided by that small change in x, right? So look, it's 1 when this is equal to 1. Now let's start reducing h. It's smaller and smaller and smaller. Look what's happening to ex. Nothing. It's 1 all the way until it's undefined, right? So that is what a basis vector, that's how you can look at the definition of a basis vector as a derivative. Just go back to the original definition of the derivative, which you knew, and look at it that way, and it all makes sense. Okay? Hope that helps.